Hi there, I'm Brendan Burns, Corporate Vice President for Cloud Native Open Source at Microsoft Azure and co-founder of the Kubernetes Open Source Project. And I'm really excited to have the opportunity to talk to you today about everything that Azure is doing with the Kubernetes and Cloud Native Open Source communities. I wanted to start with a brief history of containers because I think they may seem like really new, modern technology, but the truth is that they've been around for over 40 years. From the initial addition of the chroot command to BSD Unix in the 1970s, through the early days of the internet and jails in BSD, all the way through to the modern evolution and mainstreaming of containers with Docker and Kubernetes. I think it's really important to consider that despite the fact that this technology has been around and been in development for quite a long time, it really only gained resonance in the days of cloud, in the days of open source, and really because of the demands of application developers that they were facing in the modern era of 24/7, always on, highly scalable applications. That's a key lens to be thinking about as we think about why are these tools so important and so interesting. And I think what's also been essential to Kubernetes' success has been the development of Kubernetes as a developer-oriented API, a Cloud 2.0 if you want to think of it that way. So when you look at a managed service of managed Kubernetes in Azure, what you're seeing is an API that has primitives that are built around what developers care about, like replicated services, load balancers, HTTP traffic shaping into your applications, and not the details of infrastructure like virtual machines or disks, or low-level concepts that may be closer tied to a data center than to a modern application deployment. And the ability for the cloud to provide that API where your application can truly go anywhere, from Azure to on-premise and anywhere else, but in a managed way where the cloud takes care of things like upgrades, security patching, and reliability for you, is a huge way to accelerate the innovation and the agility of your app as you build it for today's users. As part of thinking about how we enable developer productivity, I wanted to start with the core building block of Kubernetes, which is the pod. Within a pod, you can have multiple containers sharing the same disk, sharing the same IP address. The decision to have multiple containers inside of a pod is a fundamental part of the very beginning of Kubernetes, and it was designed not around technology, but actually around teams. If you have multiple container images, you can isolate different teams' work within their own workspaces, within their own resource limits. You can have teams that push and upgrade their applications independently, despite the fact that that code operates in a very symbiotic way when located on the same machine. The sidecar pattern has emerged as one of the most popular ways to combine different pieces of software together. And with the Dapper project, which we'll see a little bit later, you'll see a great example of sidecars in action. Now, it's not just about enabling teams to push software in a more agile fashion. It's actually also about taking away things that they don't need to worry about. This is an example of a health check for a Kubernetes pod, and I think it's just a great example of how Kubernetes and cloud-native infrastructure makes it easier for developers to build reliable applications without even thinking about it. When you use Kubernetes, you can define a health check. If that health check fails, the container will automatically be restarted. You don't have to worry about setting up a monitor or setting up a daemon. It's simply a part of deploying your application out into the cluster. And that ability to learn less and yet do more is key to achieving the agility that you need in today's innovative climate. Now, one of the other pieces that made Kubernetes such a success is its open source nature. And the cloud native open source ecosystem has become an incredibly vibrant place over the last 8 years. And Microsoft does a ton of contributions to these cloud native communities, to developing new projects, supporting existing projects, whether it's delivering code into the core of Kubernetes, contributing integrations with Dapper or with Helm or with the Open Container Initiative. There's all kinds of places where Microsoft devotes its time and its energy to building sustainable communities and building tools that are productive for Kubernetes users no matter where they're running their applications. But in addition to actual code, what I'm also really excited about is the degree to which Microsoft is a leader in the community. From being some of the founding members who helped write the articles of governance for Kubernetes, through to being the release leads for various releases of Kubernetes, Microsoft has volunteered its time, its energy, and its expertise to enable these open communities to do more and to help Kubernetes and cloud native users all around the world, whether they're on Azure, on-premise, or anywhere else. We really believe that we only succeed if we work together as a community, and that this rising tide of open source innovation truly makes the cloud a better place to be for everyone. I wanted to give you an example of how this actually works in practice. This is the VS Code extension for Kubernetes that we've built and released. Importantly, it's not a tool that only works with Azure. It works with Kubernetes anywhere. Of course, we've done a really great job integrating with Azure so that it's very easy to use if you use the Azure Kubernetes service, but you can make it work with any Kubernetes cluster anywhere in the world. I want to draw attention to this one little piece of it, which is that if I right-click on a pod, I can easily discover how to port forward securely to my application. Now this might seem like a small, trivial thing for me to be highlighting, but actually it clearly demonstrates the point, which is that if we enable our developers to fall into a secure place as part of their development process, well then we're going to avoid things like this, where a developer trying to do the right thing, just trying to move as quickly as possible, also opens up a huge security hole that we discovered, that Microsoft security researchers discovered, and actually ended up with a bunch of crypto mining happening in a bunch of Kubernetes clusters, both in Azure and beyond. Right? So I think there's this massive interplay between enabling developer productivity and agility, but guiding developers into the happy path that leads to reliable and secure applications that we're focused on in all of our open source efforts. As an example of this, I wanted to draw attention to how we think about managing Kubernetes resources. Of course, you're going to be using role-based access control, or RBAC, to separate out the good users who should have access from the malicious users who obviously shouldn't. But I want to point out that role-based access control is insufficient. There's a whole bunch of questions related to security, like where did that application come from, or even something as simple as which team deployed this application, that are essential to building a secure environment, and again, enabling those developers to fall into that pit of success and do things that are secure and reliable by default. The only way to do this is with policy, and this was an early insight that we had as we saw our developers and as we saw our customers starting to use Kubernetes. Policy was a real gap in the Kubernetes ecosystem, and so Azure stepped into that gap and created a project called Gatekeeper. Now we knew that it was not the sort of thing that we could keep within Azure, keep within Microsoft, and so we donated Gatekeeper out to the CNCF, and it has become a successful CNCF open source project, and at this point is worked on by a really rich collaboration of different users across the industry who are interested in developing policy and enabling developers to deploy safely and agilely to Kubernetes wherever it happens to be. It's a great example, I think, of the leadership and what our own expertise and experience with compliance and other kinds of enterprise regimes has enabled us to bring to the cloud-native ecosystem. Now, Dapper is another great example where we're actually doing innovation for developers. If you think about Kubernetes, you can think of it as being a runtime, kind of like the JVM or the Java runtime. But if you think about the Java runtime or Golang or .NET, there's a standard library that goes along with that runtime. But there hasn't been a standard library for Kubernetes. There hasn't been anything that has been built in the cloud-native ecosystem that makes it easier for you to build your applications. Dapper attempts to solve this problem. Now, when we think about things like event handling, typically we think the easiest way to do event handling is to be in some sort of functions as a service environment. They do a great job of making it super easy to respond to events. But the trouble with functions as a service is the runtime brings in a ton of limitations in terms of programming languages, the amount of memory you can use, various forms of native code that don't work. And so what Dapper tries to do is to give you access to that programming model without requiring that you be in a particular kind of runtime environment. You can take legacy code that uses hundreds of cores, that uses tons of memory, and adapt it to use Dapper just for small pieces. This is a simple example in Java, but Dapper is polyglot. You can use the Dapper sidecar to respond to events in any language and give your applications that easy-to-use, event-driven programming model, even in a plain container running inside of a Kubernetes cluster. So that flexibility of meeting you where you are but delivering you a useful programming model is really what underlies the core principle behind Dapper. But it's not just about eventing, and I don't want to give you the impression that eventing is the only thing that Dapper does. We enable similar models for storage, where you can have the adaptability of building a container that uses the Dapper sidecar to talk to storage no matter where it happens to be. Portability is a huge piece of what Kubernetes brings to the table, and with the Dapper, you can actually bring that portability to things like NoSQL stores. So you can use the exact same code, the exact same interfaces to store data into Cosmos DB on Azure, into MongoDB if you're running on premise, or in some other NoSQL store on a different cloud through exactly the same code. This again enables your developers to do more while learning less. They can learn one simple, consistent way to talk to NoSQL that is completely cloud independent. I wanted to also talk about another area where we are pursuing open source innovation, and that's GitOps. Now I think one thing that we've noticed all of our customers do is as they start to scale out, they create multiple clusters. And as they create multiple clusters, they create multiple different configurations. Now the trouble with this is there's drift. Different configurations take on different values, and eventually some sort of outage happens because a configuration in one place didn't get copied into all of the right places where it needed to be. This is obviously a really problematic model, and so in the industry what we're seeing is a trend towards GitOps. Now with GitOps, the way that this works is you store your configuration files in a single central location, a Git repository like GitHub or anywhere else that you can find Git hosting, and then there's an operator, in this case Flux, that runs in every single cluster and monitors that single location for the configurations that it should be running. In this way, you get a scalable way to deploy consistent configurations around the world. And you can also take advantage of tools like GitHub Actions that can do integration testing, unit testing, pre-validation, health checks and rollbacks to ensure that not only are you rolling a consistent configuration out around the world, but that that rollback proceeds and results in a healthy and at-scale application. I think this is a great example of open source innovation because when we looked out into the market, we could have said, you know what, we'll write our own. But what we saw in the cloud native ecosystem was a great tool in Flux. And so instead of saying, you know what, we're going to take that open source technology and we're just going to put it in Azure and we won't contribute back, we actually started engaging with Weaveworks and engaging with the Flux community and are now actually co-developing features all throughout the Flux ecosystem that enable, yes, our Azure customers to do more with GitOps, but actually any GitOps user who's using Flux anywhere in the world can do more. And I think that notion that we want to bring the benefits of Azure everywhere in the world is also what inspired the development of Azure Arc. We have a ton of really great tools, whether it's GitHub and GitHub Actions, or the VS Code extension that I mentioned, the GitOps model, health checks, policy. All of these tools are fantastic ways for you to manage your Kubernetes cluster. And more, because of Kubernetes' portability, we're seeing developers build applications that span across all of these different environments. Now it's a pain if you have to manage different policies, different application configurations, just because you happen to need to be in different clouds or spanning from cloud to on-premise. And so what Azure Arc says is you can actually have a single pane of glass, a single way of managing your Kubernetes-based applications, no matter where those applications are running. You can have a single identity system, a single policy definition, a single application definition powered by GitOps, and you can deploy the same application to Azure, to on-premise, and to any other cloud. That consistency of experience means that you can, again, move more quickly, more agilely, and ultimately more reliably and more securely when you think about the innovations that your application needs to deliver, no matter where that innovation happens to run. I hope that that gives you a picture about how Azure thinks about Kubernetes, about the cloud-native open source ecosystem, and how we hope that we can help you do more with cloud-native computing on Azure or wherever your compute happens to be. Thank you.